One balloon riding wind, currents 20 kilometers up couldn't outrun the satellite math. No propellers, no engine, just the sky's moving air. A decade and about $1 billion later, it was shut down in 2021. Here's the setup. Roughly half the planet had no reliable internet. Billions of people. An enormous prize. Laying fiber across mountains and jungle is slow and brutally expensive. Launching satellites was, for years, even worse. So a balloon looked like the cheap shortcut. The real question, what forced Alphabet to kill a moonshot it had bet on for years? It started inside Google's secret lab, Google X, around 2011. The public pilot flew in June 2013 over Christchurch, New Zealand. The idea was simple to say and wild to build. Take a thin polyethylene balloon, the same plastic as a grocery bag, just tougher, and float it up to about 18 to 20 kilometers. That's twice as high as a passenger jet. Up there, it becomes a floating cell tower. It beams ordinary LTE straight down to phones on the ground. No new gadget needed. Now the hard parts. How do you point a balloons? You don't. There are no propellers up there, no engine, nothing to push against. So the team pulled off the signature trick. At different altitudes, the wind blows in different directions, like lanes on a highway stacked on top of each other. The balloon changes its own height, pumping air in and out. It finds a layer drifting the way it wants to go. It never steers. It just picks a lane. Elegant, right? But picking a lane isn't the same as staying put. And that gap is where the whole story turns. So here's the trap. A balloon that only picks lanes can't hold a spot in the sky. It rides whatever wind it can reach, and the wind goes where it wants. To keep steady internet over one town, you can't park one balloon there. It drifts off in hours. Instead, you need a conveyor belt of balloons. A fresh one arriving as the last one floats away, cycling in and out forever. Think of it like catching a bus that never stops. To guarantee one bus is always at your corner, you have to keep a dozen circling the whole city. Loon's answer was software. It fed years of stratospheric wind data into machine learning, pattern-finding code that predicted where each wind lane would carry a balloon next. That let one balloon loiter near a region far longer than random drift would allow. It genuinely worked, but it could not beat physics. Balloons still wandered thousands of kilometers off course. Some crossed oceans. Each one had to be tracked, brought down safely, and often recovered from a field or the sea. And every replacement is another balloon you had to build, fill, and launch. Which raises the expensive question nobody could shake. What does all that motion actually cost? Here's where it gets expensive. The early balloons lasted weeks before a leak or a failure brought them down. The team pushed hard, and later ones stretched toward roughly 100 to 300 days aloft. Better, but every single balloon still had an expiration date. That meant a factory always building, crews always launching, teams always tracking and recovering. Run the arithmetic, and the cost per connected user stayed stubbornly high. The cheap shortcut promise never arrived. And it wasn't for lack of proof that the technology worked. In 2017, Loon beamed emergency internet over flood-hit Peru. Weeks later, after Hurricane Maria flattened Puerto Rico's networks, Loon balloons carried tens of thousands of people basic connectivity when nothing else could. In 2020, it went fully commercial in Kenya, selling real service over the mountains. Each one was a genuine win. Each one also quietly made the same point. The balloons could deliver. They just couldn't deliver cheaply at scale day after day without that whole expensive machine running underneath. A disaster you can justify. A permanent business is a different math. So while Loon was proving it could fly, a rival was quietly rewriting the cost of the sky itself. That covers the how, now the why it lost. The rival wasn't another balloon. It was a swarm of small satellites in low orbit. Starlink began launching in 2019, stacking 60 satellites at a time into low orbit. It was building toward a mesh that blankets the whole planet at once. Here's the key difference. A satellite doesn't drift. It circles the Earth on a fixed, predictable path, and the next one is always right behind it. No conveyor belt of balloons per region. No recovery crews. No launching a fresh unit every few months over every town. And crucially, the price of getting to orbit was falling fast, thanks to rockets that land and fly again. For the exact same goal, connect the unconnected, satellites were becoming the more durable, more scalable bet. Alphabet saw the writing. In 2018, it spun Loon out as its own company, no longer a protected lab experiment. That move sounds like confidence. It's actually a deadline. It meant Loon now had to prove it was a real business, standing on its own revenue. Not just a clever technology its parent would fund forever. And the numbers quietly were not cooperating. In January 2021, Alphabet shut Loon down. CEO Alastair Westgarth said the road to a viable long-term business was far longer and riskier than they'd hoped. The cost simply never dropped far enough. And now the whole shape of it clicks. 1 balloons, 20 kilometers up, 0 steering. That last part was never a bug. It was the elegant core of the idea. But it was also the trap. A machine that can only ride the wind is a machine that always drifts. And a machine that always drifts needs an endless, costly parade of replacements underneath it. The physics of wind riding locked in the economics that killed it. The dream didn't die empty-handed, though. Its radio spectrum patents were freed up. Its laser-link technology, beaming data between floating points, folded into an alphabet project called Tara. And its hardest lessons flowed straight into the satellite era that beat it. Here's the one thing to carry out of this. When you hear about an elegant technical hack, the clever workaround that skips the expensive infrastructure, ask the boring question first. What does it cost to run this every single day at scale forever? Loon's balloons were beautiful engineering. But beauty that has to be rebuilt and relaunched every few months loses to a plain, repeatable machine that just keeps circling. The elegant hack usually loses to the boring, scalable one. That single test, running cost at scale over time, explains a surprising number of technologies that dazzled then quietly disappeared. Sometimes the graceful idea loses and the boring, scalable machine wins. Loon started the job of connecting the unconnected. Satellites are finishing it. So how does a swarm of Starlink dishes actually blanket the whole planet from low orbit? And can it really reach everyone? That's the mechanism we open next.